So let's graph a quadratic formula, a function. This function is called f, and we're going to graph this function. How do I know it's a quadratic? Because the leading degree is 2. So we get a quadratic. And we're going to want our quadratic written in this format. If it's written in this format, we're going to be able to graph this. So what we need to determine before we start graphing is if this quadratic opens up or downward. There will be times when it will open to the side, but for the scope of this class here, we won't be solving for them going to the side unless we did the graphing of the inverse. But however, this is a specific quadratic, and we're going to determine if it opens upward or if it opens downward. And how do I know if it opens upward or downward? Is if my A is positive. If it's positive, it's going to open upward. Okay? If it is negative, then it's going to open downward. Now remember, A is this number on x squared. B is the number on x to the first. And C is my constant. Okay? So, let's determine. So, looking at this specific function here, we notice that our parabola, let me clean this all up. Our parabola is going to open upward. It's going to open downward. Excuse me on that. Because it's a negative A, right? It's a negative 1 for A. So it's going to open downward. Now what we're going to do is find the center of axis, in center of symmetry, basically, where's the center of the parabola? So we're going to look for this point right here. So we're going to use our vertex formula. And on the vertex formula, we're going to have an order of pair. Well, we know an order of pair is x comma y. But in this case here, we're looking for a center. And the center for x is h. And then for y is k. So this is my center. Now, we are going to solve for it. Well, how do I know how to solve for h and k? Well, for h, we're going to take negative b over 2a. And whatever we get here, we're going to plug it into the function. And this function's called f. It may get a function that's called b or g or whatever it may be. But this function's called f, so this is what we're going to plug in. So let's solve for it. Let's find the center first, and then we can graph it. So let's solve for h. H is negative b over 2a. Well, what is b? Well, if we look at it, we see that b is a positive 14. It's important that you notice the positive because we would have to plug that in, right here. But it's not, if we plug positive in here, positive times negative is still going to just stay negative, right? It's not going to change. But it's important because it could have been negative, and then negative times negative would change. So this is why it was important to recognize the positive. 14 is 4, so it's a positive 14. Again, if you need to put it there, go ahead. And then my A is a negative 1. So now let's solve. I have negative times positive is negative 14. And then I have negative 1 times positive 2 is negative 2. Well, negative divides negative is a positive, and 2 goes into 14 7 times. So now I know that so far my center is a 7 for x. Now let's find out what k is. K says I take whatever my answer was for h and plug it into my function. So now we have this as our function, and everywhere as I see x, which is called my h, I'm going to plug in 7. All right, so now once I've done that, I can solve for it, for k. So I have negative, and then 7 squared is 49, so it's a negative 49. And then we have 14 times 7, and that's 98, and it's positive. Minus 47. So I'm going to read left to right. I'm going to say negative 49 plus that 98 minus 47, and it gives me positive 2. So my k is 2. So let's go over here and graph that. So I'm going to start at 0, 0. My x is positive, and it's 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. My y is positive 2, so I'm going to go up 1, 2. So this is my HK. This is my center of this parabola. It's also my axis of symmetry, right? So my axis of symmetry would be where x is equal to 7. Okay, so let's figure out how the rest of this quadratic's going to play out. Well, we said it opens downward. So if it opens downward, right, we know it's going to cross the y-axis, or excuse me, the x-axis. If it opened upward, we wouldn't have no x-intercepts, right? But in this case here, it's open downward because a is negative. So now we need to figure out where does it cross the axis, x-axis. Where does it cross at? So what I would do is I would pick some point on this side of my axis of symmetry, the center, and some point on this side. And it doesn't matter which point you pick, but whatever you pick, remember you're plugging it back into the equation. So I want to say, let's pick, so it's at 7, let's pick 5, where x equals 5. You could have picked 0. I mean, you could have. I'm going to pick where x is equal to 9. Alright, so I'm going to take this function here, this f of x function, and everywhere is a cx, I'm going to plug in 5, right, and see what I get. And then I'm going to do the same for the 9. Whoops. Let's clean this up. And I will do the same for my 9. So, now I got negative 5 squared. 5 squared is 25, so negative 25. And then I'm going to add it to my 14 times that 5. And then I'll subtract 47, and it gives me a negative 2. So, at where x is equal to 5, we got 1, 2, 3, 4, 5. My y is negative 2, so right here. Alright, so now let's try when f of 9. Alright, so let's plug in 9 everywhere. Let's see x. So now I got negative times 9 squared. 9 squared is 81, so I have a negative 81 plus 14 times 9 minus the 47. I get negative 2 again. So that worked out great. So over here for 9, I get negative 2. Okay. So y is negative 2 when x is 9. So now I can make sure it's curved a little bit because this is a parabola, so it's kind of curved. My drawing's not perfect, but that's how you graph using the vertex formula. And if we want to talk about the domain and range, let's do that for a second. Let's talk about the domain and range here. The domain is all x values, right? And whenever I read the domain, I always start right here from the negative infinity, and I go into the right, to the positive infinity. And what do I see? I see that I have this arrow that's continuously going out and this arrow that's continuously going out on both ends. So that tells me it's just going to end up eating every one of the x values. So it's all real numbers for my domain, which is negative infinity to infinity. So this is interval notation, and this is just a notation saying all real numbers. Now let's talk about the range. Well, the range is my y values, and we always read bottom to top. So if I start down here at negative infinity, I'm going to go up, right? We're going to go all the way up to positive infinity, or as high as we can possibly go. Well, what do I see? I see that at least one of these arms that are going downward has a arrow on it. That means it's continuously going down. That means it's going to get all the negative values, right? And then we're going to follow this up until we see this point right here where it's closed at. It's closed at where y is 2, right? So that means we're going to stop there. My range goes from negative infinity to positive 2. So this is solving, this is graphing a quadratic and being able to state the center of axis is symmetry. If you wanted to see where it crossed the x-axis, we would plug in 0 for y and use the quadratic formula and solve for that. And then it'll give us the points that it actually crossed on the x-axis. And then to find where it crossed on the y-axis, wherever this may be down here, you'd plug in 0 for x, and what happens? You get a negative 47. So I know my y-axis is going to be crossing down here at negative 47. Thank you.